Alright, so in these examples we have some heftier, I don't know if that's the right mathematical term, it's definitely not formal, because they're heftier in the sense that there's more things going on, there's more operations here. But my tip is to do the last operation that happened, right? So the last operation that happened, yeah. So the idea is, okay, I've got this, and how would you build this expression over here? Well, if you started with x and you added 1, and then you divide it by 2, that's how you'd get the expression on the left-hand side. So if I want to undo that, think about like untying your shoelaces, right? The last thing that happened was this division by 2. So if I want to get rid of that by multiplying both sides by 2 here, right? The opposite operation is still very key. So multiply both sides by 2, and then what I'm going to do is I'm going to end up with, remember this fraction goes away when you do that. On the right-hand side, I got 11 times 2, which is 22. And then I can subtract both sides by 1 because that's the opposite operation that's there. Opposite of adding 1 is subtracting 1. So I get x is equal to just 21. Alright. Again, we can check that by putting it into the original equation. So 21 plus 1 is 22. Divided by 2 is 11. Alright. So that's how we can solve the following equation. And we can apply this to all these kinds of examples here too, right? So if I take this guy, the last thing that was done here was this multiplication by 5. So I'm going to do the opposite of that, which is, sorry, the last thing I was done was division by 5. And I can do the opposite of that by multiplying by 5. And so I'm going to left with 7 minus x is equal to negative 30. Right? And then now what I want to do is I want to think about, oh, well, this 7, that's a positive 7. Yeah. So I'm going to do the opposite operation of that, which is subtracting 7. And so I end up with negative x is equal to, now, be careful, negative 30 minus 7, check on your calculator, but you'll get negative 37, alright? And so the last step is, well, you can think about this in two ways. If negative x is equal to negative 37, then x is just equal to 37. If you want an operation attached to that, what you can think of is, you can think of just multiplying both sides by negative 1. Alright, last couple. Now, these ones are slightly different because remember how I said the thing you want to do, this thing we're going to start with is the last operation that was there. Think about how you'd build this expression. If I have x and then I divide by 3 and then I take away 4, the last thing that happened in this case was not the division, it was the subtraction by 4. So I want to undo that bit first, just like my shoelaces, right? So I want to add 4 first for these ones. So add 4 to both sides. That's going to remove the negative 4 there. So x on 3 is equal to 2 plus 4, which is 6. And then we can do this as per normal. We can think about, okay, well, I've got a fraction here, that's division. So the opposite of that is multiplication by 3. And so I'm going to get x is equal to 18. And I just want to emphasize that it's not necessarily the only way to approach this question. But I think when you do it in this way, where you think about the last thing that was there and then you undo it, it makes the equations much more approachable to solve. Alright, last one here. I'm going to try this one. Pause the video, have a go for me, and come back. Alright. Hopefully you had a crack. So what I'm going to do is I'm going to start with this addition by 3 here. So what I'm going to do is the opposite of that is subtraction by 3. And so I'm going to get b over 2 is equal to 7 minus 3, which is 4. And then last but not least, the opposite of dividing by 2 is multiplying by 2. So I'm going to get b is equal to 4 times 2, which is 8. And that's our final answer. Let's check it for good measure. 8 divided by 2 plus 3 is equal to 4 plus 3. And lo and behold, that is 7. Okay, that's how we can approach these kinds of questions here, where we have to not only think about solving equations, but solve them with fractions as well. Hope that helps.